Clear. Several monitor and several earphone and listen to a different Zoom meeting. Okay, so 61 student. What happened to the rest? Okay, shall we start or are we going to wait? What happened to you? Class at 9 also cannot come ah? And I do class at 8 ah? Or next time I'll do quiz in the first 5 minutes. 5% of your final mark. Random quiz. Every time I see less student, I'll do quiz. Round started late, some of them are still in rounds. You can leave the round early, what? You're not presenting also. Okay, never mind. I'll just record this. By the way, do you have anything, any question before we start? I'm sorry, I haven't uploaded anything in Putra Blast yet. I'll do it over the weekend. Okay, been quite busy this week. I'll upload it over the weekend and then on Monday lah. Supposedly I want to cancel this class today. I want to go back to Kelantan. Mahal. I change. Maybe I'll go back next week. Okay. Or poster. Okay. Okay. For today, it's gonna be a short lecture. It's not gonna be long because I have another sampling today. Right after this, I have to go down to postmortem. Want to join also can. Okay, for today, I'm going to talk about avian immune system. Okay, before we go to all the diseases I want to, I'm going to lecture on diseases in fourth lecture or something. Before that, we need a lot of introduction because during the lecture, there will be a lot of terms and stuff, things that I will just say it because I already introduced it beforehand, especially the vaccination. Okay, there's a lot of all the diseases that I have in the lecture later on. We do have vaccines against them. So you have to get familiar with the vaccination. So the first one is avian immune system. Okay, before I proceed further, avian has contributed a lot in the field of immunology. Not immunology in general, not just avian. Okay, immunology in humans as well. Is the graft versus host responses and the role of lymphocytes in adaptive immunity was first described using chick embryos and chickens, and also the bursa of Fabricius, okay, is the first proof that the B cells was being produced. Okay, the role of B cells in the humoral immunity. Okay, in the original, the B stands for bursa. Okay, the B actually stands for bursa because it was first found in chicken. What they did is they removed the bursa of chickens. Okay, they removed the bursa, the bursa of chickens, and then what happened is the birds are unable to develop antibodies. Okay, so they know the role of the bursa is to produce antibodies, and at that time also they know the role of antibody in immunology, the role of antibody in immunology. And the fourth one, when it comes to vaccination also, okay, the first attenuated vaccine was first developed by Louis Pasteur against fall cholera. Okay, it's a bird. Actually, this is an accident. Okay, they accidentally found it. They accidentally call it left the Pastorella maltosida isolates the bacteria over several weekend or several days or something, and then the bacteria continually growing. Okay, he went to what call it vacation or something, and then the bacteria become attenuated, and then they did use Yeah, okay, let's try. If I inject this into birds or something, and then somehow it developed immune response, but it did not develop diseases. So the first attenuated vaccine. Okay, and also first vaccines against naturally occurring cancer, Marek's disease lah, was developed for chicken. Okay, now I know for women or men can take the vaccine as well. Are you familiar with HPV? Uh, human papilloma virus, herpes. Yeah, HPV, human papilloma virus that can cause like genital warts and whatnot, especially and also cervical cancer. Okay, if so most of the girls is if you haven't go get vaccinated because you can get this disease as well, and you may develop like cancer in later on, and then that's after the Marek's disease vaccine has been developed. Okay, and then so let's go to the immune system. Immune system in chickens can be divided into primary lymphoid organs and the secondary lymphoid organs. The primary lymphoid organs are the thymus, okay, which are responsible in the cell-mediated immunity, they're producing the T cells, maturation of T cells, and the bursa, okay, for the development of the antibody for humoral immunity. And other than that, we have spleen, cecal tonsil, bone marrow, lymphoid organs, and lymphoid aggregates. Okay. The difference between chickens and mammals is chickens do not have lymph nodes. Okay. Do not bother to palpate lymph nodes if you do physical examination for chickens. Okay. Because chicken do not have lymph nodes. What they have is they have lymphoid cell aggregates. Means like they have a sort of like node. It's not really a node. It's like a accumulation of lymphoid cells at certain parts of the body. Hadrian glands located near the eye. Gut associated lymphoid tissue. Bulb, bronchial, mucus around the teeth. Heart is what heart associated lymphoid tissue somewhere near the heart. So it's everywhere. Okay, if you open the intestine, sometimes you see like at the part of the intestine, they enlarge a bit. They enlarge a bit. If you do a histology there, you see a lot of lymphoid organs surrounding that area. Okay, those are sort of like the alternative of lymph nodes in mammals. Okay, the chicken do not have lymph nodes, so they have lymphoid organs. In avian system for the thymus, which is the one of the primary lymphoid organs, there are around 7 to 9 lobes along the jugular vein. Okay, that's what I'm going to do sampling today. I need to take the thymus of chickens. Okay, it's along the neck. You can palpate it. You can see it from under the skin. Sometimes it's quite huge, unless they have problem or something. The development of this one starts from day 5 of the incubation in the eggs. Okay, they develop since they are in egg size. Okay, and then the timers, they can regress over time. Okay, within 2 to 3 4 months of age or around that, they start to regress. Then, if you open a very old chicken like layer chicken, breeder chicken, they don't have timers anymore. Okay, and similar to bursa of Fabricius. Bursa of Fabricius is an organ located at the cloacal region on top of the cloaca. It's like a ball, it's a nodules like that, it's a sac. Okay, and then inside the sac, if you open it, it's a lot of folds inside it. Okay, so folds. I think you have done postmortem in chickens before. Okay, if not, I don't have picture at the moment. I have picture later. Okay, they contains lymphoid follicles and lymphocytes in producing the plasma cells, and they mature into B cells. The development of the bursa of Fabricius is around 4th day of embryogenesis, which is in the eggs. Okay, 4th day of incubation in the eggs. Then they also involute the regress over time, starting 4 to 8 weeks. Okay, and then they start to disappear around 6 to 12 months. Okay, if you open all chickens, they don't have bursa of Fabricius anymore. Okay, because sometimes I bought what do you call it? Layer chickens, old layer chicken, expired chicken. Okay, for postmortem for the VM5. Okay, I asked them to look for bursa of Fabricius. Okay, they say the chicken doesn't have bursa, which is supposed you're not supposed to find. And also, you have to get familiar also with maternal antibodies and immunity, which is from the mom to the hand, from the hand to the chicks, egg yolk to the embryo. Maternal antibody lasted for how long? Any idea? Have you opened a chick before? Okay, the egg yolk in chicken usually fully absorbed. The egg yolk is the nutrient for the chickens during the early stage of life. So they are fully absorbed within one week. Okay, but the maternal antibody usually lasted around 2 weeks. Okay, the maternal antibody is humoral immunity. Okay, in general, okay, this is the anatomy. They have Hadrian gland near the eyes there. The thymus is along here. Okay, the nodule is not here, but it's somewhere around here. So it's usually along the line here. Okay, we have cecal tonsil at the cecum area, at the beginning of the cecum, at the spleen inside here, bone marrow. Bursa of Fabricius is supposed to be around here. They don't, in this picture, they don't have it, but it's supposed to be a nodule here. Sorry, using wrong monitor to show you. Okay, a nodule here. Okay, nodule here. Peyer's patches are lymphoid aggregates along the intestine. Okay, these are the general anatomy of lymphoid organs in chickens. Okay, and then when it comes to immunity, the immunity defined as the ability to resist infections from normal exposure to a disease. There are different types of immunity. Have you taken immunology yet? Already, right? Okay, then this is quite easy. We have inherited immunity to natural resistance, characteristic of species, strains, and breeds. So you know, like some chickens, some animal, some birds, or some human are naturally immune to certain diseases. Some people are actually naturally immune to COVID as well. Small percentage of human population, they cannot get COVID. They also have, some people are also immune to HIV. For example, in certain part of the world, they have this island, they have a genetic mutation or something. Some people are immune to certain diseases. That's quite interesting. Okay, and then active immunity. We also have acquired immunity. We can divide it into active immunity and passive immunity. Acquired means you acquire it through active immunity is through exposure to pathogens, whether you're exposed to the natural or field exposure or through the fake exposure, which is the vaccination. The immunity can be humoral or cell-mediated immunity because it really depends on how the body responds towards the disease. Okay, usually have a longer duration, and they do have memory. That's why you get vaccinated. Okay, they have memory. Again, after you get vaccination, and then you get infection with the real disease, then you got protected against it. Another one is passive immunity, which is achieved from the external source, transfer of antibody from mother to eggs or from anti-serum injection. But for poultry, we are talking about the mother to eggs passive immunity. Anti-serum injection is only in human lah. We don't do anti-serum injection for. Okay, it's only humoral immunity because you literally inject antibody. You inject the serum, only the antibody is working. Okay, they usually have shorter protection because antibody have a lifespan. They don't last forever. Okay, they don't have memory as well. Okay, they don't have memory as well because you're injecting the antibody. You are not injecting the B cells. B cells is the one that have memories. Okay, B cells producing the antibody. So the antibody shorter protections, okay, and have no memories. That's why, like I said just now, for chicken, for maternal antibody in chicken, they only lasted about 2 weeks. In summary, humoral immunity are produced by B cells, and simulated immunity are produced by T cells, and we have a lot of lymphoid organs for the mechanism of immunity. I'm not going to go through a lot of mechanism of immunity because I know you have taken your immunology. Go revise your immunology class, how what call it, B cells work, how T cells work, how the immune response work after vaccination and whatnot. Okay, and then when it comes to disease control, we do have good. We have to rely to certain things. Number one is biosecurity measures and good management. Okay, to prevent disease entrance. Okay, I always tell farmers. Okay, they do have a, what you call it, a sequence of order when you want to control disease. Number one is biosecurity. If you have very good biosecurity, you are sure your farm is located like hundreds kilometers away from other farm. There is no other visitors and whatnot. You don't even bother about vaccination and medication because there's no way your disease can come to your farm. Okay, but that's not always the case. Okay, so that's why you complement it with vaccination in case it happens. Okay, it's like COVID situation. Okay, biosecurity, social distancing are biosecurity. Stay at home is also biosecurity. Wear mask is also biosecurity. But it's not always the case. We have to go out. We have to meet people. So we complement is vaccination, extra protection. Okay, even if you get the virus, then you don't get sick, you don't die or something. Same as chickens, you may get the virus, but you don't die 100%. If you got ND, you don't lost 100%. Maybe maximum 10%. So at least it's not a total losses. And then if things goes west, go south, okay. Uh so and then it still happen, then you proceed with medication. For vaccination, vaccination is a tool for achieving disease control through acquired immunity, active and passive immunity. Vaccines can be divided into live virus, kill virus, and actually and also like bacterium. Bacterium is also like bacteria vaccines. It's basically live or kill virus also. Okay, we do have characteristic of ideal vaccine. We have to choose the best vaccine. There's a lot of vaccines in the world against poultry. Okay, I can show you a list. Let me see. Uh, see. Okay, let's see poultry vaccines that is available in Malaysia. Can you see the screen? Right. Okay. This is all the screen. Newcastle disease vaccines.
Doctor,
Yeah.
the table you're sharing is actually small on the right. We are looking at your file manager right now.
File manager.
All the folders and files, that's what we are looking right now.
It is one.
Okay. Okay. That's good.
Oh wait, so I'm sharing the wrong screen. I thought I shared the small one. Okay, never mind. This is better. Okay. Yeah. My screen is the second screen actually. Okay, this is the list of vaccines. Okay, that's available in Malaysia. There's so many of them. They have the live vaccine, kill vaccine, even Newcastle disease alone from different companies. Okay, are registered in Malaysia. This is Newcastle disease. They are like, you see, how many pages is this? 7, 8, 9, 55 vaccine just for Newcastle disease. And then we're talking about infectious bronchitis. How many more? Okay, we have 18 here registered. This is the one, the folder is 2018. I think in 2022, we have more registered. Okay, we always bring in vaccines. A lot of companies want to bring vaccine. Infectious bursal disease. Okay, this is list of approved vaccines in Malaysia. Okay, so many. We even have this called recombinant vaccine of things. Okay, they combine together AE, fowlpox, ND, Adroit syndrome, and we have NDIB together. Okay, so poultry vaccines out there like so many. This is the list of vaccines available in Malaysia for all species of animal. But you see here, okay, 78 pages is just for poultry vaccines. Okay, out of 100 pages. The rest is for other animals. Okay, so how many is that of the poultry vaccines in Malaysia? So wait, so I'm sharing the wrong screen. Never mind. Oh, saya stop sharing. Saya balik share screen one. Okay. So we do have a lot of vaccines. So what to choose? There's a headache. There's 7, 8 pages of vaccines. How to choose which is the best vaccine for your farm, or which is the best vaccine to farm. So that we do have a lot of characteristic of ideal vaccine. You want to find the best vaccines, and there's a lot of advantages and disadvantages of live and inactivated vaccine. You have to think what is the best. You have to plan accordingly. Depends on the best way to use at the farm, whether it is necessary or not. Okay, when it comes to vaccination planning, there's a lot of factors have to be considered. Your demographic, your location, what is the strain infecting Malaysia right now, and also what are the biosecurity of the farm. Okay, how's the management? If your biosecurity is very bad and something, you have to improve your vaccination, because for sure they will get diseases. So you may want to booster them so many times. If the vaccination is really good, you want to save on vaccination. Okay, so we do have the conventional live and kill vaccine. They come in single form, bivalent form, trivalent form, polyvalent form. What does it mean by bivalent, trivalent, polyvalent? Bivalent, trivalent, polyvalent means the combination. Okay, like you see just now, ND, EDS. We call it, that one is bivalent because it's combination of two disease. Trivalent, if ND, IB, IVS, it's called trivalent. Polyvalent is more than that lah. Organism of the same or different genus. Live vaccines, okay, usually are developed from apathogenic or very low pathogenic strains. For example, in Newcastle disease, we find a strain that doesn't cause much reaction to the bird, but they can produce the same immune response to protect against the real infection, the more pathogenic strains. Okay, so you want, or what you can do is you attenuate them. Okay, what you do is you take the virus, the pathogenic one, reduce the pathogenicity by continuous passage in laboratory. Because grow, when the virus grow in not what do you call it, non-natural environment, for example, eggs in the cell culture, tissue culture, they will reduce their ability to cause diseases. They reduce their pathogenicity. So if you will see this 52 or 120 means that there has been passage many times, up to 52 times in the lab or in the eggs or in the cell culture, up to 120 times. Then only the virus, okay, become good enough that cannot cause diseases, but can produce immune response. Okay, the another one is kill vaccine. So you don't attenuate them, you simply kill them. Okay, they don't have the ability to replicate anymore. Okay, it's either from apathogenic, low pathogenic, or pathogenic strains. We kill them with formalin, beta-propiolactone, or other chemical compounds. Okay, they usually use as secondary or booster vaccines, and they require addition of adjuvants, all alum or plant-based. Any idea what is the role of adjuvants? Immunology, ada ajarkan vaksin. Slow release the vaccine into the system. Not really. In a way, yes, but not really. What's the role of adjuvants actually? Okay, one of the main function of adjuvant is to cause immune reaction. Okay, because all these viruses are dead, they are killed. Okay, if you inject a kill thing, something that cannot replicate, sometimes the body cannot detect it as a antigen. Okay, it's a foreign body. They just, okay, nothing, no immune reaction, no antibody production. So you inject with adjuvant. You mix it with adjuvant, all alum or plant based, so that it increase the immune response towards this vaccine or virus inside it. Okay, so what happened is the body will detect, oh, this is a foreign agent. Okay, let's consume it. The macrophage and everything comes together. Let's engulf it and produce antibody against it. So that's how it works. Okay, so that's why you have to be very careful when you are dealing with kill vaccines. So for those of you who haven't go to farm yet, please be very careful when you are dealing with kill vaccine. Why? Anybody went to poultry farm and then you get the chance to inject chickens into the breast muscle, to the what, or the injection lah. Okay, using kill vaccine. One of your senior had before suddenly accidentally injected the kill vaccine into their fingers, to her fingers. It's swollen and become black. Okay, the reason is because of this oil and everything. It caused immune reaction. Okay, it caused immune reaction towards his hand or something, and it's so swollen. So it could happen. Necrosis could happen as well. So you have to be very careful. Okay, it comes to okay. These are the criteria of an ideal vaccine. You want to find a vaccine that is stable and safe. What does it mean by stable and safe? Any idea? All this. Okay. Any idea? What does it mean by stable and safe? Okay, stable are safe. Your virus are not viable. Need to keep it alive. Okay, stable and okay does not cause disease. That is true. Okay, you want to find a vaccine that is safe, that they does not produce. They cannot what do you call it, return back to our original form. One thing, safe. Safe means if you use kill vaccine, it's definitely safe in a way because they already dead. They already dead. They already dead. They cannot replicate. They already dead. Because some vaccines, okay, can replicate and then regain its original form, the attenuated one. They regain the original form, become the pathogenic agent again. So those are the things that you want to avoid. Okay, this has happened in human as well. Back then they used live vaccines for polio. It happens in US in 1 second, and then the person get the virus, the original virus strain, because the virus mutate back to original form. Okay, this happened same as in human. In chickens also, we call it the rolling reaction. Another definition of safe is they do not cause a lot of adverse effect. Okay, some vaccine can cause immunosuppression. Some vaccine can cause certain things to happen, like for example, bursa atrophy. Marek's disease vaccine can do that as well. Some vaccine can cause several side effects. Okay, swollen of the head, they look weak, reduce in egg productions or something. So those are the definition of safe. They don't have a lot of adverse side effect. Okay, all these things, criteria of an ideal vaccine is applied also in humans. Okay, they did a rigorous trial when it comes to producing a vaccine for human as well. That's why most human vaccine are kill vaccine. They want to be as safe as possible. Second one, you want to be cheap, of course, because you want to vaccinate millions and millions of chickens. It can cost a lot to the farmers. So you want to be as cheap as possible. Okay, if possible, you want to spend only like 1 cent or 2 cents per vaccination per chicken. Okay, and then third one is easy administration. Okay, so you want to say easy administration is you want to find a vaccine that, if possible, you want to use less labor as less as possible. One worker can vaccine 1 million chicken. Okay, compared to you need a lot of hundreds of workers. Okay, different vaccine. Some vaccine can be given through many ways. One way is injection. The injection one is the one that is hard administration. Okay, because you literally have to inject one by one. 1 million chicken means like you will inject 1 million chickens lah. Okay, the best vaccine would be the best is spray vaccination. You spray like spray nyamuk like that. Go to the farm, spray. Okay, and then one person can do that for 1 million chicken. Okay, that one you want to look for lah. Okay. Even COVID vaccine also nowadays they develop a vaccine that doesn't require injection, which is good. Okay, they call it the needleless vaccine. The pump like that. So it's good for kids actually. So the vaccine goes into very small molecule and then they use air force to force it into your skin. Okay, if COVID vaccine can be administered via spray, that would be good because you can also vaccinate the people that don't want to be vaccinated. You just open the spray at the mall, everybody get vaccinated, even though they don't want to get vaccinated. That would be good. Okay. So we also want a vaccine that is strong, long-lasting protection. Okay, because then it will be cheap as well because you only need to vaccine once and no more vaccination. Like Marek's disease vaccine. Marek disease vaccine only given once at day O, and then it lasts for the rest of their life. Newcastle disease, not really or something, but because you have to keep booster, the immunity reduce over time. Okay? And also you want to have a heterologous immunity. Heterologous means like they can protect against various diseases. Okay, heterologous and not various diseases. I'm sorry. Yeah, various diseases. Heterologous. The combination of IB, ND, and whatnot into one vaccine. So that you don't have to have three times of vaccination to three different diseases. One vaccine can cover three diseases. Okay, and you want fast onset of immunity. The soon you get the immunity, the better, because you don't know when are you going to get the challenge. Okay? And then induce various immunity. Induce various immunity. For example, you want the vaccine, if possible, can induce humoral immunity, cell-mediated immunity, mucosal immunity, and many others. Okay, all this immunity. So that would be the most ideal vaccine. And then the last one is they can also break maternal antibody. The maternal antibody does not interfere with them because most vaccine you want to vaccine them as early as possible, but due to the presence of maternal antibody, maternal antibody can like neutralize the vaccine. They kill the vaccine and then does not produce immune response. So you want vaccine that does not interfere with maternal antibody. Okay, these are the comparison of live and inactivated vaccine. Usually I don't have this slide. Your senior, so I don't have this slide. Okay, when when you want to compare live and kill vaccine, the safety, usually the live one. Oh wait, this is wrong. Live one, okay, live one is less safer than the kill vaccine. Okay, so I baru tulis pagi ni. Ini, okay. The safer one is usually the kill vaccine because they cannot spread, they cannot mutate. Okay, but they can also give vaccine reaction, but it's okay. It's a little bit compared to live vaccine. Live vaccine usually have more vaccine reaction. Okay, and then economical. Usually the live vaccine is more economical. Like I said just now, live vaccine is usually given through spray and drinking water. Kill vaccine, you have to always inject it. Okay, because kill vaccine, they're already dead. You cannot put in drinking water. If they drink, they like drink water only. They cannot replicate in your mucosa to cause immunity. So all the kill vaccine, all the injectable vaccine are kill vaccine. All the kill vaccine are injectable. Okay, sorry, the other way around. Okay, because live vaccine can still be injected. Mass application, live vaccine can do mass application. You can give drinking water or you can give through spray. But kill vaccine, you have to inject one by one. Rapid onset of immunity, usually the live one have rapid onset immunity compared to the kill one. Usually around 2 weeks, then only you get the protection. It's like COVID lah. Your COVID vaccine is kill vaccine, right? You know, right? Okay, so then only after 2 weeks you have to show your MySejahtera. Then only you can go to malls and whatnot. Uniformity. In live vaccine, is yes or no depend on how you vaccinate the chicken. Because for example, if you give through drinking water, you cannot ensure that all chickens drink the water. So uniformity might be various, depends on how you manage the chickens. Or spray. If you spray only in front of the farm, then the chicken at the back do not get the vaccine. Kill vaccine, you can enjoy uniformity because you literally inject one by one. Okay. And then now, and the third one is the combination of antigen available. Yes, we have live and kill vaccine that can combine antigens together. And then maternal antibody interference, usually the live one usually interfered with by the maternal antibody, and the kill one is not really. Okay. And then when it comes to vaccine, you also have to properly handle the vaccine. This is one of the factors related to vaccine failure. For all vaccine should arrive with full packs in well-insulated box. Storage temperature is around 2 to 8 degrees Celsius, which is the chiller, not the freezer. The freezer is minus 20. The chiller. Avoid freezing, extreme heating, and intense light for all vaccines. For live vaccines, transport to farm in cooler with ice packs to keep temperature constant, and you mix with diluent reconstitute just before application. If I want to go vaccination class with you, it's going to be very long because I usually teach farmers how to vaccinate chicken, how to mix. Because you have to mix them, and then the water have to have ice, so you don't want the chicken to die, and the water have to be finished by 2 hours because the virus will die within 2 hours. Okay, for live vaccine. For inactivated vaccine, you remove 24 hours prior to vaccinating so that the product can warm to the room temperature. Do not leave bottles in direct sunlight during transport to farm, and gently agitate bottles prior to use. Okay. And then we also have other types of vaccine we are looking for when it comes to vaccination strategies. Okay, we keep always doing research for this one. Okay, all this one you don't have to actually memorize lah. This is more like sharing. That won't come out in your exam also. Okay, for this one only, the rest can for this particular subtitle. Why are we looking for other type of vaccine? Okay, we want to have more best vaccine that have higher safety. Even now also they keep doing research for best COVID vaccine. Prof. Hair also is doing research in COVID vaccine also. He went to VRI every week, okay, to trial in mice and whatnot. Okay, maybe we can produce our own COVID vaccine soon. Okay, some RNA virus vaccine have high mutation rates, FMDV, IBV, IBDV. Overuse for a long time may result in emergence of new pathogenic isolates. Okay, does need to improve vaccines. Kill vaccines are usually safer. So when it comes to cost, you want to have a new methods of production of cheap vaccines, reduction in labor, time, and equipment use. Wait. Okay, and efficacy, usually long-lasting. You are single vaccination, able to break maternal antibody, live vaccines, able to replicate induced humoral and cellular response. And for administration is best, you want to find the best way to mass administration. Okay, combine vaccine of different serotypes, strains, or subtypes. So you only give one. You don't have to give so many vaccines. Okay. These are the new trends in vaccine technology. Okay. We have recombinant vaccines, anti-idiotype vaccine, subunit vaccine, DNA or RNA vaccine, marker vaccine, and transgenic plant as vaccines. Okay. Okay, this is the one that won't come up. The previous one can come up because it's related. Sorry, this one. Okay, recombinant vaccines using virus or bacteria as vector. What happened is recombinant vaccine, like you see just now, the HVT, we take the protein, F protein from Newcastle disease, we insert into the virus of the fowlpox. Because fowlpox is a big virus, okay, we insert them. So we inject into the chicken, and then the chicken can be protected against fowlpox and also the Newcastle disease. Or Marek disease virus also, HVT. HVT is usually used as vector as well. All the big virus can use as vector. Adenovirus can be used as vector as well. Okay, these are all the things. Adenovirus can be used as well. Salmonella typhimurium can be used as well as vector. And anti-idiotype vaccines, you literally this is more like what do you call it? Humoral transfer. Contains antibodies and against antigen combining site of natural antibodies. So you does not require isolation and delivery of infectious material. So basically, you transfer like antibodies kind of things lah. Fully immunogenic and subject to immune response gene control. And then we also have subunit vaccine, synthetic peptides. they're using like expression system. They have some virus also. They combine together. They only take a portion of that protein subunit. We call it the antigen. They inject the antigen only. Okay, so that your body can detect the antigen. And then we also have RNA vaccine or DNA vaccine. You're supposed to be familiar with this one. Okay, means like you inject the RNA and then the body will develop the RNA encode or DNA, the produce DNA, the encode the protein that is similar with the antigen. Okay, the disease antigen. So they will produce the proteins. Okay, this is what your Pfizer vaccine is. Are you familiar with it? You all get vaccination, but you don't know what your vaccine you're getting. Okay, Pfizer vaccine in Malaysia, we have different technology. Pfizer vaccine using what technology? What vaccine in Malaysia? We have in Malaysia Pfizer, AstraZeneca, Sinovac. Okay, Pfizer is RNA vaccine. How about AstraZeneca? What technology are they using? Any idea?
DNA, doctor.
No, AstraZeneca is not DNA vaccine. Recombinant, yes. AstraZeneca is a recombinant vaccine. They take the protein of the COVID, they insert it into adenovirus of chimpanzee. What you get is the virus of chimpanzee actually, if you're taking as AstraZeneca. Okay, the virus of chimpanzee, they put inside there to be the vector lah. How about Sinovac? What technology are they using? Kill vaccine, yes. Sinovac is a kill vaccine. So Sinovac are not using the modern technology. They use the conventional one. Okay. I don't know why some countries they do not accept Sinovac. Maybe because of the protection is less or something. That is Sinovac vaccine using the most common technology, which is kill vaccine. All your vaccines that you had when you are a child are kill vaccine. Using that technology. And then we also have marker vaccines. You deletion mutant viral vaccine. You delete a certain gene, okay, so that they become the virus. We'll call it become a mutant that cannot produce disease, but can still produce immune response. You can allow differentiation between infected and vaccinated animals for this one is for diagnostic purposes. Okay. Another one is also transgenic plant. I don't think chicken have. Chicken don't have, but we do have in other disease in animals. Okay, rabies vaccine. They use plants. They insert the antigen into the plant gene. Okay, they inject or consume the plant gene. Okay, so vaccination. We have a lot of routes of vaccination. I think those who have been to LI should know this. We do have intranasal, intraocular, intramuscular, spray, in ovo, drinking water, feed, subcutaneous, wing stab, and scarification. We have a lot of vaccination routes. So different vaccines have different vaccination recommendation. So not all vaccine can be applied. You can simply apply only. Okay. So for example, pox vaccine. Vaccine is given through wing web. Okay, that's the best way. Usually when they develop vaccine, when they develop all these vaccines, they did a trial already. We do research. What is the best way for the animal have the best protection? Okay, we try in ocular, we try in nasal, we try to drinking water, we try spray. Can it produce the best protective immunity? Those that produce the best protective immunity, then that's the one that we recommend to use in this particular vaccine. When they develop vaccine, they will try everything one. Okay, what is the best way? Even for injection, they also try which part of the body is the best part to inject. They inject in the muscle, in the thigh, in the wing, so in different part of the body. So usually when you purchase any of the vaccine, they will come with a pamphlet lah. Let me see. Okay, I have vaccine here. I don't know whether you can see it. Okay, stop protection, stop sharing, so you can see my face. See my face. Why am I seeing environment face? Okay, never mind. As long as you can see it, okay. So usually vaccine comes like this. These are the live vaccine. Okay, this is the live vaccine. Usually live vaccine comes in this kind of vial. Vaccine expired ni. Okay, this of water bottle. Okay, this kind of vial. Small vial like this. This vial, the dose is for 1,000 chicken. Okay, so it depends on, usually this kind of vial is for drinking water or intraocular or nasal kind of things. The small one like this. So what happened is I put the diluent inside, shake, 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 shake. It has to be in, and then for uh for eye, I will put into the dropper and then drop into the eye. Okay. For kill vaccine, usually they come this big bottle like this. Okay. This one is I don't know for how many dose. 300 ml. 1,000 juga. Okay, 1,000 dose juga. Okay, dia dah. Yang ni inject terus, tak payah dilute apa semua dah. Masuk. Yang ni for ND, IB, EDS, ART. 4 sekaligus. Polyvalent vaccine. For Newcastle disease, infectious bronchitis, 8 drop syndrome, and avian rhinotracheitis. So, jimat. Yang ni Lasota ni untuk ND sahaja. Okay. So, that's how they produce the vaccine lah. The vaccine cost varies. Usually yang Lasota ni murah je. Dalam RM15. Usually RM15 to RM20 like that. But we do have vaccine yang mahal. Ada yang satu vial ni RM300. Okay, yang tu mahal lah. Okay, murah je. So, there's no excuse for the farmer not to vaccinate the chicken lah. Okay, usually I teach farmers how to vaccinate. I go to farm and teach them. Okay, back to sharing. Okay, and then, okay, this is how they do for drinking water. Intranasal, inject, you put it into the nose. Spray, usually do at hatchery. You put them under a cupboard and then just spray on top of them. Intraocular into the eye. Usually all the vaccine have dye, the blue dye usually. And then if you the eye, the tongue will become blue. Wing wet, okay, step into the wing. They have using this needle, okay, this unique needle like a fork there, dua ni. So you dip into the vaccine, and the vaccine will stuck in the groove there. You can see the groove small here, the small groove there, okay, and then you inject it. After 1 week, you can see this vaccine reaction. If you don't see vaccine reaction, if too many chickens do not have vaccine reaction, we call it vaccine takes, then most likely your vaccine did not work or your vaccine died already or something lah. Okay, so you have to monitor vaccine takes as well. And intramuscular, you inject into the breast muscle like this. They use a muscle vaccine gun. So in the backpack contain the vaccine, you just pack masuk je. Okay, inject one by one. It's quite fast. Okay, subcutaneous vaccine, you inject on top of the skin. Subcutaneous vaccine. Okay, there are several factors. Dah nak habis masa ke? Okay, cepat lagi. There are several factors influencing the vaccination in the field. Number one is the host itself, the general health of the host. When you are a baby, or now, when people say if you are sick, don't go to vaccination yet. You have to be healthy to get vaccinated. Immunological maturity. Okay, you have the immunology immune organ have to mature first. Maternal antibody interference, vaccination, the types of vaccine selection, the vaccine dose, the routes of vaccination, the timing of the vaccination, okay, and the stability of the vaccines, the environment, the concentration and distribution of field virus, okay, system of management of the farm, the reservoir of diseases, and the legislation related to the vaccines is called under environment as well. Okay, how do you differentiate vaccine and immunization? Any idea? Are they the same thing? What is vaccination and what is immunization? It sounds similar. Anybody? Okay, vaccination is a method of delivering modified pathogens, okay, to promote active immunity or antibodies for passive immunity. However, immunization is a process by which an individual immune system becomes fortified against an agent known as the immunogen. Okay, a farmer can confirm they have done the vaccination, but a farmer cannot confirm all chicken has been immunized because there's a lot of factor that determines the immunization. If the farmer injected a expired vaccine, okay, you can say, oh, the chicken has been vaccinated, but the chicken has been immunized yet because the chicken did not induce immune response against the vaccine. So we can be sure that we vaccinate a chicken, but we cannot be sure that the chicken become immunized. The only way to sure that chicken has become immunized is by taking blood and then check the antibody titer. Okay, there's a lot of numbers, there's a lot of reason how vaccination failure. Farmers always complain to me, Doktor, I dah vaksin lah, vaksin tak berkesan lah, ya, company ni. Okay, so that's a complaint. So you have to explain to them, there's a lot of reasons. It's not just related to vaccine efficacy. Okay, there's a lot of loss of potency, for example, faulty storage and handling, insufficient immunity, erroneous dilution, you over dilute it, improper vaccination techniques. If a vaccine is a live vaccine, you can give through drinking water. If a kill vaccine, you cannot give through drinking water. They must be injected. Okay, or else the chicken will not be immunized. Ineffective vaccination, you're already you're vaccinating already sick birds. Wrong vaccination schedule. You give vaccine too early or too late. Okay, too early we have maternal antibody interference, or too late during certain period of time, for example, peak production or something, they are immunosuppressed or something, so you have to do a proper schedule. Maternal antibody interference, okay, similar with wrong vaccination schedule, wrong serotype or petotypes, then challenge strains, okay, because certain diseases have a lot of serotypes or petotypes. Okay, you have to find the proper one. If in Malaysia we have this serotype, and then you import vaccine from Africa or something, it's not similar with the Malaysia situation. You will not get protection. It's similar with the COVID vaccine lah. They said the Delta, the Omicron. They said the current vaccine cannot really protect against Delta because they're actually different strains already. Okay, the similar concept. Stress and immunosuppression. If the chicken has been infected with immunosuppressive diseases, then the vaccine may not work as well. Challenge pathogen is too strong. Sometimes, okay, unlikely, but sometimes your vaccination was done really nice, very good and everything, but you are unlucky. Your farm was infected with a very strong virus that can overcome the vaccine protection. Okay, it can happen as well. And then wrong route of administrations. Okay, so some people ask me, what is the vaccine schedule? Doctor, what is the vaccine schedule of a farm? It's very difficult because, like I said just now, there's a lot of like hundreds of vaccine registered. Okay, so there is no one schedule fit all. So you have to adjust accordingly what vaccine you want to purchase, what are the timing. So, but we do have guidelines lah. Okay, this vaccine should be given at 2 weeks, at 3 weeks, following that booster or something. We do have a guideline, but if you go to different farms, they have different vaccine schedule. It's not like cats and dogs. Okay, there's 6 in 1. That's all. For the rest of 6 in 1. Okay, 5 in 1. For horse, this 3 in 1 or something. For chickens, you have to adjust accordingly. If your farm have never had fowlpox, why vaccine against fowlpox? Okay, if your farm have no challenge, there's no chances. Your area have low chances of having this disease. Okay, never been reported of this disease. Then you don't vaccinate. You have to adjust accordingly. Okay, so that's all for today. I think it's almost time. Any question? reading chat also. Okay. Any question? Do you have class after this? Wait, there's no class after this because after this is also my class. My class is supposed to be until 11. Oh, so I can extend actually. Okay, any question? How about our attendance today? Yeah, I still forgot also lah. Okay lah, I consider you all attend lah. Never mind, wait. Let me see the participant. 104. How many in your class? 111, is it? How many your classmates? Don't know also.
Should be 115, I guess.
115. So 11 people didn't come. Okay. Who didn't come? Raise your hand. Okay. So that's all for today. You have any question? If there is none, I think that's all for today. Have a good weekend, everyone. Enjoy your weekend. It's probably the last weekend before bulan puasa. We still have next Saturday lah. Yeah, still almost the last weekend. If you want to do any activity outside, go swimming or something. Any haram activities. Okay. Okay. See you guys. Have a good day. Sampai Jumaat. Jangan lupa sampai Jumaat. Bye bye.
Thank you, Doctor.
Thank you, Dada.